Hello and welcome to my YouTube channel. Today we are starting a new series of videos for Kubernetes crash course, especially designed for .NET developers. But if you are coming from any other background, for example Java or any other languages, you can continue on this course. But the examples what we are going to follow in this series is especially designed for .NET. So let's start. And uh, before we start, let's understand the Kubernetes architecture, and we will do more practicals, and I'll try to keep the theory as short as I can. But understanding the Kubernetes architecture is very important, so let's dive in. And before that, if you remember, we created some videos for Dockers. So how we created the Docker containers, let's try to recap and then we can move to the Kubernetes architecture. So if you remember from the previous video, we were having some Docker files uh, for our project. So Docker files contains the instructions to create the images. If you will see, we are having multiple instructions. We are having the base images and then some other instructions to create the Docker image. And then we started reading that instructions and we created Docker image. So this Docker image is, we can say, it's a bundle of your application and its dependencies. And more in the coding word, if I will say, it is kind of class, but when we create an instance, then we can use that class, right? So now we are having image, but to use that image, we need container. So from the Docker image, we can create the Docker container, and under the container, our application is going to run it. Now moving to next, what is Kubernetes? So if you remember in the previous few videos, we created Docker containers and then we found like if we are having a multiple containers, so manually running all that containers will be challenging. Then we came to we got an idea of Docker Compose. So Docker Compose, we find out like Docker Compose is a orchestrator tool which run the containers. So similar to that, Kubernetes is also open source container orchestrator tool used to deploy and manage containers. So it is having a more benefits compared to Docker Compose, and we will see that in the upcoming videos. Now moving to next. Now let's move to Kubernetes architecture. So here we can see that we are having one cluster, that Kubernetes clusters. So what is a cluster? If you will see under the cluster, we are having nodes. So we can see that we are having like one master nodes and then multiple worker nodes we can have. So we can say cluster is a collection of nodes, and if you will see under the like what is the role of master nodes and worker nodes. So master nodes is used to manage the worker nodes, and we are having a different components under the master node. So let me show the components of master nodes. So yeah, these are the components of master nodes: API, server, etcd, scheduler, and controller manager. So what is the role of API server? So all the communications is happening from master nodes to the worker nodes. Uh, Whatever the communication we are happening is going through the API server. So whenever worker nodes wants to communicate with the master node, so it is going through API servers. Then next is etcd. So we can see that we are having multiple worker nodes, master nodes, and lot of other stuffs. So all that configurations we need to store somewhere, right? So etcd is nothing but a key value pair, uh, we can say storage to store all this configuration. And now next is scheduler. Scheduler is used to schedule pods on the worker nodes. So what is a pod? We will talk about that in the some upcoming sessions. But for now, let's say pod is like we have container, And on top of that, we have one more wrapper, so container running inside the pod. And this scheduler is helping to create a pod under the multiple worker nodes. So we have these different worker nodes, and based on the availability, based on the storage and capacities, scheduler is scheduling a pods to available on worker nodes. And this control manager is responsible for overall cluster management. So if something is going wrong, then control manager will going to take care of that. Next, now we have talked about the master node components. Now let's discuss about the worker node. So let me, yeah. So in the worker node, like we are having this components API server, etcd scheduler and controller manager in the master node. Similar to that, we have this kubelet, kubeproxy and container runtime in the worker nodes. So kubelet, so whatever communication we are happening through API server is going through kubelet. So we are having kubelet, and kubelet is taking care for running a pods inside a node that is also responsible for kubelet. Now kubeproxy, so all the networking steps, load balancing and communication between the pods is taken care by kubeproxy. And number third is a container runtime, right? So as I mentioned, we are having a containers which is inside the pod, right? So to run that container, we need something, some mechanism. So that is what we are having this container runtime, and that is responsible to start a container or stop the container or restart the container. All that thing is doing by the container runtime. Now let's talk about the pod. So pod is the smallest deployment units, and as we discussed earlier, like our container is running under the pod. So if you will see this image, this is our worker node, and under the worker node we can have multiple pods, and this pods can have one or more containers when it is sometimes we need requirements to run more than one containers. We sometimes we call it as a sidecar containers, and we are going to discuss that also in the upcoming sessions. So for now, you just understand like this is a worker node, and under the worker node, we can have a pod that is running our containers. So now let's see this in practical, and now let's try to create one pod. So before we create a pod, make sure your development setup is done, and there is a very good documentation available on Kubernetes websites. So here if you will come on the tools, you can see that to install this kubectl that is required to create a pods and other stuffs in the Kubernetes, we have defined all the options available for different operating system. If you are on Linux, you can follow this. If you are on Mac, you can follow these steps. And if you are on Windows, you can follow this as well. This is for Linux, uh, different steps, and it is self-explanatory. And this is for Mac as well. And similar to that, we have for Windows. And another easiest approach for Windows, especially, you can install Docker Desktop, and then you can enable the Kubernetes in your environments. So, and another thing is I'm using WSL on Windows to install this kubectl, and that I have already covered the steps to install this, and I have this video available for same. So I can share this video link in the description box, and if you want to uh, go through Ubuntu and minikube with WSL, then you can follow this video as well. Otherwise, you can create, you can install the Docker desktop and enable the Kubernetes. That is one thing. And if you are on different operating systems, this steps is already mentioned in the Kubernetes documentation, so you can follow that. So now I hope you have installed the kubectl with the different approach available, maybe with Docker desktop or different steps mention on Kubernetes documentations, and kubectl is working in your machine. I am on the WSL with Ubuntu subsystems, and let me start my kubectl environment. For that, I need to use minikube. If you remember our previous architecture discussions, so we need one cluster, right? And under the clusters, we are having the different nodes. So Minikube is very helpful for the development environment, and it's kind of dev clusters. It creates the dev clusters, and then uh, we can start Kubernetes on top of it. So let me quickly start Docker service first, and then uh, let me start the Minikube. So my Docker is running. Now let's me start the minikube. So this is a command I'm going to execute to start the minikube. You can directly run the minikube start, but due to some limitations, I am adding few extra parameters to run only on one CPU core. So you can maybe skip this command. So I'm starting the minikube cluster. So now my minikube cluster has started, and we can see that kubectl is now configured to use minikube. So now let's clear this first. And remember we talk about the nodes, right? So let's check how many nodes we are running. So I can run command like kubectl get nodes. So we can say that we are having only one node. For development purpose, it's fine. We can continue with the one node, and it will be a master plus worker node as well. So you can see that roles is a control plane. Control plane is nothing but master nodes. Now let's clear this, and we are going to create a pods. So before that, let me show you if I have any existing pods available uh, in my Kubernetes namespace, that is default namespace. By default, minikube is creating a default namespace. So now we can run command kubectl get pods, and we can see that we don't have any resource available. You will let me run kubectl get all command, so it will list out all the resources, and we can see that only the cluster is Kubernetes cluster is only running, and we don't have any other resource available. So let's clear it. So as discussed previously, pod is a kind of wrapper on container. So containers are running under the pod, and container we can create through Docker image, and Docker image we can generate through Docker file. So we need some Docker image to create this container and then run our pod. So for this first pod creations, we are going to use Nginx Docker image. So let's start. So this is Nginx image available on Docker Hub, and we are going to use it. So let's open our terminal, and to create a pod, we cannot directly create it in the latest Kubernetes version. We need to create it through deployments. So I will create a deployment, and then deployment will create that pod. So let's run command kubectl, then create deployment. Then we can give any name. So let's give name as a first pod. Then here we need to define our image. So if you will see our image, it is Nginx. So we can say Nginx here. And if you want to install any specific version, so you can define the version also after the colon. You can give any version, or maybe we can say latest. And if you are, we are even if you are not defining the version, then also it is going to take the latest version, and let's hit enter. So we can see that deployment is created successfully, and now let's run kubectl get pods. So now we can see that it created one pod, and it is prefixed with the name what we have defined in the deployment, and then some random dynamic string is appended after the deployment name. Now let's see the deployment. So we can say that we have this first pod and it is still running. So because of that, it is saying 0 out of 1 is ready. So just let's wait for some time. And now let me run the kubectl get deployment command again after waiting for some time, and most hopefully this time it should create it should be in the ready status. So let's run kubectl get deployments. So now we can see that 1 out of 1 is ready, and even let's see kubectl get pods. So our first pod is also up and running. So congratulations in the Kubernetes crash course, you have successfully created the smallest unit of Kubernetes that's called pod successfully. And as our pod is running, and we know Nginx is run on port 80 by default. So let's see if I'm able to access Nginx or not. So let me run local host 80 and then hit enter. I'm sorry. So we can see that we are not able to reach it because we did not expose it, right? It is still under the container. So let's verify if I will try to execute this inside the container uh, and if I'm able to access our Nginx or not. So if you will see in the Kubernetes documentations to uh, you know to get a shell to a running container, we can use this command, and here we just need to give our pod name, then it will be execute, and we will get the shell for to run the container to run the commands. So maybe we can copy this and modify this as per our need. So let's go back here and let me paste it. Oh, I did not copy it completely. Let's remove this. Let's copy this, paste it here, and now just change the name of our pod, which is this one, right? So let's copy this and paste it here. And now we can get the shell to run the command inside our pod, right? So let's hit enter. Great. So we are inside the pod, inside the container now. Now let's run ls command to view the files. So I can see all the files for our deployments. Now let's run curl http localhost 80 and let's hit enter. So yeah, we received the HTML page, and we can see that if you see this page, the Nginx web server is successfully installed and working. So before we end this Kubernetes .NET Developers Crash Course of this session of part 1, let's have a quick knowledge check. So here you can see question one of the components of master nodes, and there are 4 options. Out of 4, 1 is a correct answer and 3 is incorrect. So you need to think about our previous discussion about the Kubernetes architectures and think about the correct answers, and maybe you can stop the video now and share the correct answer. For example, like question one, correct answer is EDCD, kube proxy, kubelet, whatever you think. So you are having 10 seconds. Now your time starts. Okay, so correct answer of this question is one of the component of master node. As we discussed in our previous discussions, it is etcd. Now moving to the next questions, and for all the questions you will have 10 seconds. I will recommend you can stop the video and give your answer in the comment box. So moving to next. One of the component of worker node. So previous question was for master node. Now this question is for the worker node. So again we are having these four options, and think of the correct options out of this four. You can again stop the video and put down your answer in the comment box. You have 10 seconds and your time starts now. Okay, so correct answer of this question is container runtime. Now moving to the next question, and that is the last question of this. This is for kubectl commands. So what command we use to list list down the available pods? Again, there are four options. Think of our previous discussions and maybe stop the video and write your answer in the comment box. You have 10 seconds and your time starts now. Yeah. So correct answer of this question is kubectl get pods. So that's all for this part. Soon I will upload the next part of this video. Thank you for watching.